Breathing, something you have done for every minute of every day of your life. But how do we actually perform this task that is so critical for keeping us alive? What structures are involved? And how does it truly support so many other organ systems in your body? In this series, we're going to be exploring the respiratory system and some of the key structures that are involved. Now, given that we have just finished with the cardiovascular system, it's important that we really keep in mind how closely both of these systems are connected and how they really work together. So when we are looking at the circulatory system, its primary responsibility was transport. It is to transport nutrients, oxygen, all this sort of good stuff to the tissues whilst removing waste, such as carbon dioxide. And it did this by a process called internal respiration. Now, this works hand in hand with the respiratory system in that one of the main features that we are seeing here, and this is something we're going to be exploring in a moment, is pulmonary ventilation. So, pulmonary meaning lungs, and ventilation to ventilate, to move air. So pulmonary ventilation is the process of moving air in and out, and we also have external respiration. Now, it's important that we don't get these muddled up. External respiration is the exchange of oxygen and carbon dioxide between the lungs and the blood. Internal respiration is the exchange of oxygen and carbon dioxide between blood and tissues. So please be very careful with that distinction. Now, looking very briefly at some of the sort of main anatomical features of the heart, what we see here is that we have our right lung and our left lung, but you'll notice they don't quite look the same. Our right lung is actually bigger than the left lung. So the right lung has 3 lobes, whereas the left lung has 2. Now, the primary reason for this is because of this little feature here, the cardiac notch. So the reason why the left lung is actually smaller is because our heart's in the way. Now, in the same way that we explored with the cardiovascular system or looking at the heart and we looked at that coronary circulation, the same principle is true when we're looking at the lungs. So when we looked at the heart, how the blood flowed from sort of the atria to ventricles and then out again, yes, blood was moving through the heart, but it wasn't as though there was any gas exchange or any exchange of nutrients or removal of waste during that step. The heart has its own separate coronary circulation to do that function. The exact same thing is true when we look at the lungs. So when we're looking at our pulmonary arteries and pulmonary veins, that is entering into the hilus of the lungs, but that is not where we are seeing nutrients and oxygen being delivered to the lungs. No, this is where the blood is being oxygenated for the rest of the body. So looking at our basic anatomy here, we're going to be breaking things down into 2 main zones. We are going to be looking at the conducting zone and the respiratory zone. Now, the distinction between these two is very important. The conducting zone, its primary role is movement of air. Something else that you're going to notice me do throughout this entire series of videos here is clearly changing my terminology. Whenever we are talking about the conducting zone, I will always be using the word air, because the air that we are breathing right now is not just one thing. It is not just oxygen. It's comprised of many other things, of oxygen and carbon dioxide and nitrogen and water, humidity, stuff like that. However, when we are talking about the respiratory zone, that is where we see the movement of oxygen into the blood and the movement of carbon dioxide out of the blood. So you'll notice in the conducting zone, I refer to it as air because it is moving air in and air out because there are multiple things in air. Whereas in the respiratory zone, we're being a lot more specific. We are looking at the specific movement of key compartments within air. So oxygen moving in, carbon dioxide moving out. Now, our main game plan here, guys, is to start off with the nose, and we're going to work our way right down our trachea, down into our alveoli. So let's get started. So starting off with the nasal cavity, okay? Starting off with our nostrils. What's very important here is the histology. Now, when I say histology, what is it that I'm talking about here? Histology essentially means like the tissue type. So when we are looking at our nose and our nasal cavity and our nasopharynx, which is sort of like the very back of your throat, what that tissue type is ciliated pseudostratified columnar epithelial tissue. Now that's a lot to take in. That is a whole heck of a lot of syllables. So let's break it down. Ciliate. What does cilia mean? So cilia are these microscopic hairs that we can see at the top of our epithelial cells here. And what they essentially do is they do the Mexican wave. They are constantly flowing backwards and forwards to push substances along its surface. And in the case of our nose and nasopharynx, that it's essentially mucus. Pseudostratified. So pseudo means false, and stratified means multiple layers. So what this means is that it looks like it has multiple layers here, but it actually doesn't. Columnar means it's like a column in shape, and it is a type of epithelial tissue. So it's always good that we learn to break down these words so it's easier to understand their meaning. Now, what we also see with these epithelial cells here is the interspersal of goblet cells. Now, what do goblet cells do? They create mucus, they create snot, essentially. Now, given that we are breathing through our nose, what is the function of all of this? What are we trying to do here? There are three main objectives that these epithelial cells are trying to do before this air that we are breathing right now enters the lungs. It is trying to warm that air up. It is trying to filter that air and clean it, make sure there's no sort of pollutants or anything in there. And we are trying to humidify it, so add moisture to it. This is why if you breathe on a glass window, it will fog up because of the moisture that you're breathing out. So as we are breathing air and it's coming up through our nose and coming into the nasal cavity, there is two main structures here that I really want to hone in on, that I really want to focus on, and that is the nasal concave and the nasal meatus. Now, what we are essentially looking at here, they kind of look like bookshelves, and their role, their function within the respiratory system is the almost polar opposite of what we saw with that epithelial tissue inside of our heart and inside of our blood vessels. So in our blood vessels and inside of our heart, what was the purpose of it? It was to ensure laminal flow. So nice, smooth, one directional flow of anything that's passing through it. The nasal concave and the nasal meatus, they want the polar opposite. It wants turbulence. It wants to spin and push and maximize that movement of air in the nasal cavity. Why? Why would we want that? Because we essentially want to maximize the exposure of air to these epithelial tissue. Again, why? Well, we want to warm the air, we want to filter it, and we want to moisten it. And the best way to do that is to make sure the air is coming in contact with these cells. And we do that by making turbulent flow. So what our focus will be moving on now is that we've very briefly looked at the function of the respiratory system, and we've started with the nose, working our way up. What we're then going to cover is looking at the pharynx and the larynx. So I'll see you in the next one.